effect of temperature. Next factor affecting the ROR, rate of reaction, is effect of temperature. So how can we say this one, how temperature is going to affect the rate of reaction? This can be well explained by one scientist, that he is nothing but Arrhenius. He derived some equation for that. And finally, he concluded that if we increase the temperature, K is also, rate constant is also going to increase. So finally, rate is going to increase. Rate of the reaction is going to increase if we increase the temperature. So what is the Arrhenius equation? He derived a relation between K and T. K equal to A into exponential of e to the power of minus EA by RT. Here K equal to, we know that one, rate constant. A equal to, this is Arrhenius constant. Arrhenius constant, or we can say pre-exponential constant also, because before the exponential it is coming. So pre-exponential constant. And EA is, we know that one, we studied just now, activation energy. R equal to gas constant. What is the value of R? 8.314 joules per mole per Kelvin. And temperature, here it is in Kelvin, so temperature should also be taken in Kelvins. Temperature in Kelvins. This is important for your numerical sums. So this is the relation between K and T. So if T increases, K is going to increase. So let's discuss about this thing. If we take this one, ln of K, that is equal to ln of A e to the power of EA by RT. So ln of K equal to ln of A into B, that is nothing but ln of A plus ln of B. So ln A plus ln of e to the power of minus EA by RT. We are doing simplification. ln or log base E, both are same. So if we write this one in terms of log base E, so what's happening here? What is the formula? Log base x to the power x power A, that is equal to A only. So log, if we write this one in terms of log E, ln or log E, both are equal. So log E to the power of EA minus RT. Log e to the power of minus EA by RT base E. So what we'll get? Only minus EA by RT. For calculation purpose, we are writing like this. ln K equal to ln A minus EA by RT. If we convert this one into log base 10, we should multiply the whole thing with 2.303. Convert from ln to log base 10. We should multiply everything with 2.303. So I'm converting ln of K to log base 10K. So we need to multiply this one with 2.303. And again, this one also, ln A, I'm converting this one also with log base 10. So 2.303 log A base 10. So from this, what we'll get? Log K base 10 is equal to, we should divide the whole thing with 2.303. Log A base 10 minus EA by, we should divide this one with also 2.303 RT. So this is our expression. This is our relation between K and T. So if suppose here we need to consider two cases. First case is, if at all, let's take the temperature as T1. For temperature T1, rate constant will be K1. And after some time, if temperature is T2, then let's consider rate constant is equal to K2.